notifications. Now, the SDO satellite was officially launched on February 11, 2010, and the SDO eclipse season occurs in February or March and in August versus September. August, September. But in 2010, there was no eclipse season in March. So the first eclipse season was in September of 2010. Images from this eclipse season are seen here in 335 angstrom, so extreme ultraviolet again. And here we can see the sun going dark. I don't think this is the first day of the eclipse because the sun goes completely dark on that day. And as you can see, so it's getting progressively darker and then light emission resuming. And we can see the corona shrinking as well, like before, even though the corona looks smaller in this wavelength. But we can clearly see that the corona shrinks in several of these images. You can see even here looks smaller than it does there. So it's clearly shrinking already. We can see it looks smaller here than there. So the same thing occurs that occurred in 2017. Now these images are between 6:40 and 7:07 UTC. The eclipse usually lasts at least 30 minutes, sometimes up to 69 minutes. And this image is from 7:07, and that image is repeated here. This image is from 7:08, and the difference in the two images is astounding, because as you can see how much brighter the sun seems to be in just 1 minute. And there is no way the Earth would have been down here by then, somewhere down here. Okay, so it would have been just here. You can see it actually here somewhere, and it would have been just maybe here. In order for us, if this was an eclipse, we know it's not an eclipse. But how does the sun, with the Earth not being anywhere near Earth, suddenly become so much brighter in 1 minute? And look how much the corona has grown from 1 minute to the next, all around. On the other side of the sun, as well as this side of the sun, the corona has grown dramatically. The sun has become so much lighter in just 1 minute. Notice this coronal hole that is visible here on the left side of the sun. Look, it seems to have shrunk in size. So the size of the coronal holes has to do with the light emission as well. And obviously the coronal holes grow in size as the sun loses light emission, and they decrease in size when the sun regains light emission, obviously because the object that holds the sun's electric potential, which drives its light emission, has moved away from the sun. And when it moves away, the sun's potential comes back and it regains full light emission. Then at least it did. I didn't see this ever happening this clearly in subsequent years. This only seems to have occurred in 2010, but the dramatic difference is amazing.